Welcome to the factory method pattern, one of the original gang of 4 creational patterns. By the end of this video, you will recognize it in a code base, understand why it exists, write a minimal version yourself, and know when to reach for it versus when to leave it on the shelf. Imagine you have a class, maybe a logistics manager, that internally calls new truck whenever it needs to ship something. That works until you need to support ships too. Now you have to crack open the manager class and add an if-else. Every new transport type means another edit to a class that was already working. You are violating the idea that finished code should be closed to modification, and your tests become fragile because you can never substitute a fake transport. Here is the everyday picture to keep in mind. A food court operator knows it needs meals, but it delegates the actual cooking to specialized stalls. The operator's workflow never changes. It just asks for a meal and receives one. Adding a new stall does not disturb the operator at all. That delegation relationship is precisely what the factory method pattern formalizes in code. The pattern has 4 named roles. The product interface is the contract that every created object must satisfy. ConcreteProduct is each real implementation, truck, ship, and so on. Creator is the class that owns the factory method. It calls that method internally, but does not implement it. ConcreteCreator is a subclass that overrides the factory method and says, when asked, I return this specific product. Client code only ever talks to creator and product. The concrete types stay hidden. Let's walk through this step by step. First, the transport interface defines a single deliver method, that is our product contract. Truck and ship both implement it. Those are our concrete products. Next, the abstract class logistics declares CreateTransport as an abstract method. This is the factory method itself. Notice that plan delivery calls CreateTransport and uses whatever transport comes back, but it has no idea which one. Road logistics and sea logistics are concrete creators. They each override, CreateTransport, and return the specific product they are responsible for. Finally, the client function at the bottom accepts any logistics instance and calls plan delivery. It never mentions truck or ship directly, so adding a new transport type, say air logistics returning a plane, means writing one new class without touching anything that already exists. The magic is that the creator calls a method on itself, CreateTransport, which is resolved at runtime by whichever ConcreteCreator was instantiated. This is polymorphism doing the work, so the business logic in plan delivery stays completely stable. The open-closed principle is honored because new transport types arrive as new classes, never as edits. The honest trade-off is indirection. You now have 2 parallel hierarchies, one for creators and one for products. So for very simple cases, that overhead is not worth it. Factory method earns its place when you genuinely expect new product types to appear over time, and you want to add them without reopening existing classes. It is a strong fit when the creator class has substantial business logic that should be insulated from creation details. Skip it when you only ever have one concrete product, or when a plain if-else or a lookup map is simpler and equally maintainable. Not every creation decision needs a class hierarchy behind it. To recap, the factory method pattern moves the responsibility for object creation out of your business logic and into a dedicated, overridable method on a creator class. Subclasses own the which concrete type decision, client code owns none of it, and adding new variants becomes purely additive. Keep it in your toolkit for extensible product families, but resist applying it before that variation actually exists.